Introduction. The great success of shale gas exploration in North America has attracted increasing attention from petroleum geologists in the world. They are passionate about finding more commercial shale gas in other countries. Although the success of shale gas exploration in North America leads geologists to believe that shale gas exploration has a good prospect, how to find the sweet spot of shale gas in shale strata is still the main obstacle we need to face in the shale gas exploration and development. Sequence stratigraphy is a relatively new concept of stratigraphy and is a powerful tool to subdivide the stratigraphic intervals into geologically realistic and cyclic patterns and to predict the stratal patterns, the lithofacies variations, and the petroleum reservoirs within a chronostratigraphic unit. In the past 40 years, the sequence stratigraphic studies mainly focused on the coarse-grained siliciclastic and carbonate deposits and on the fine-grained turbiditic systems from lacustrine to deepwater settings, leading to a great success in the conventional petroleum exploration. However, only limited studies on the high-frequency sequence and sedimentology have been conducted to study the sequence stratigraphy of shale strata deposited in deep water or restricted shallow water environment. According to the traditional sequence stratigraphy, it is difficult to carry out a sequence stratigraphic analysis in relatively deep water areas where the shales are deposited. This is due to the relatively homogeneous and fine-grained nature of the shale interval and to the conformity contact between upper and lower strata. Only newly acquired seismic data tied to geology can characterize the partial reservoir parameters, and it is very challenging to pick surfaces reflecting sea level changes of fine-grained deposits on the seismic data if not tied by core and log data. Also, the GR log alone sometimes does not indicate high TOC of the maximum flooding surface within a sequence. Nevertheless, some researchers have integrated the geochemistry, the geomechanics, the core and outcrop analysis, the seismic data, the well logs, the petrology, and the paleontology in order to perform a sequence stratigraphic analysis of the shales aimed at understanding the sequence boundaries, the major transgressive surface of erosion, the maximum flooding surface, the stacking patterns, the lithofacies variability, and the depositional models within the sequence. Some geologists have even tried to establish the criteria and models for sequence stratigraphy study in marine shale and predict the good reservoir potential shale gas vertically and laterally. So far, sequence stratigraphy of the shale is still poorly understood, and the traditional seismic stratigraphy approach to recognize the boundaries of sequences in system tracts does not work well for the fine-grained shale due to their relatively homogeneous fine-grained nature. Recent advances in property tests of the geochemistry, the mineralogy, the petrology, the petrophysics, and the geomechanics have provided the basis for the detailed characterization of the sequence stratigraphy of fine-grained shales. This lecture analyzes the spatial and temporal variations in the lithofacies, the well logging responses, the geochemistry, the mineralogy, the hydrocarbon content and aims at developing the sequence stratigraphic frameworks for representative siliciclastic dominated shales, marine barnett, Woodford, Marcellus, and Maury in the USA, Long Maxi and Qing 7 shales in China, and carbonate-dominated shales, Niobrara, USA. The general variation trends of the shale properties have been analyzed within a sequence stratigraphic framework, so that they can be used to regionally correlate the shale strata in a systematic manner and to identify, to predict, and to map the high-quality source rock and the productive fine-grained shale reservoirs.